I'm out here at the Glen Sebastian Nature Trail. For those of you that aren't familiar with the Glen Sebastian Nature Trail, I'm actually kind of on the northwest part of campus. Now behind me is part of 3 Mile Creek. It's actually dammed up. It's made a nice little pond with what I call the Indiana Jones Bridge behind it, that kind of rickety bridge that goes across. But the reason that I'm out here is we're going to be talking about groundwater today, and we're going to be measuring the groundwater table, and we're going to be looking at how the groundwater elevation changes depending on where you are back here in the Glen Sebastian Nature Trail. One thing you may not think about when you think about the Glen Sebastian Nature Trail is that there's a lot of water that's moving through here. Now, it's kind of interesting. Usually March is wet. This March it hasn't been very wet at all. We haven't gotten very many rainfall events. But yet, here I am at a pond just outside of the parking lot. So the parking lot's there. Here's a pond, and look down at the base of this pond. There's a little dam. And if I zoom in, you might be able to hear it. There's flowing water. Okay, so there's water coming out of this pipe right here. There we go. There's the pipe. So the question is, well, if it's not raining, ground's pretty dry. There's no streams or rivers beyond this pond right here. So where's that water coming from? And the answer is it's coming from groundwater. This is basically a spring-fed pond right here. So groundwater is moving through the sediments, it's moving through the hills, and then eventually it's finding its way in this pond. It gathers up and it drains out of this pipe right here. And then from this pipe, it enters another pipe along with that sewer drain right there, storm sewer. It goes across the road here, the end of the street. And I can see more trails down there. This will take you back to campus to my left. Lots of people out enjoying the day. Another drain here. Follow it, and here we go. You can see that water is leaving, and that water is flowing, and it's entering into 3 Mile Creek. And then from 3 Mile Creek, it flows basically eastwards across city, it moves downtown, and eventually it finds its way to the Mobile River, out into Mobile Bay, and into the Gulf of Mexico, where the hydrologic cycle is basically completed. So the purpose of today's lab is to take a look at that groundwater, figure out where the groundwater begins, where we've reached what's called the water table, or the level of saturation. And we're actually going to be able to map the water table using the small devices we call wells. So here's an example over here of a hand-drilled well. So students that take my hydrology class, upper level geology class, will install these wells for us. And it's basically just a pipe. It's got a screen section. This one's probably about 8 feet underneath the ground where the groundwater can flow in. We could hook a pump up to this if we wanted to, and we could get water. So groundwater is actually a pretty important resource. If you live over in Baldwin County, chances are your water supply that comes out of your tap is groundwater. So let's start making measurements. So the interesting thing about groundwater is that, like water on the surface, groundwater is going to flow from a higher elevation to a lower elevation in most cases. In other words, groundwater flows downhill. So if we know the water table elevation in 2 points, we can figure out which direction water is moving between them. In other words, imagine you have 2 points, water table elevation, water is going to move from the higher point down to the lower point. So all we need are water table elevations. Well, how do we get that data? Well, we can use our wells. So a well is an access point to the water table. That's essentially what it is for us. And we can use an instrument, a device, it's really simple, called a water level indicator or a water level meter. Okay. The idea behind this is it's essentially a glorified tape measure. You have this long tape right here. It's got numbers on it. The red numbers are going to be marked every foot. So here's 2 feet right here. Here's 3 feet right here where my thumb is. And then in between we have black numbers that represent tenths of a foot. And then in between those black numbers, we have little small dots that represent 1/100th of a foot. So we can measure the depth to water from the top of the well in up to hundreds of feet, okay? So how does this work? Well, at the end of the water level indicator, there's a weight, basically. This thing hangs straight down to pull the tape tight, but there's also a metallic body and there's a small electrode in the middle, just a small little wire there. You can see it. I get up close. And the way that this works is if you're around water, if this thing gets submerged in water, there's going to be water that basically covers this outer metallic body and gets the inner pin wet. And there's just enough conductivity in that water, electrical conductivity, for this to complete a circuit. So it's basically like a switch. All you need is water to connect the body to that little pin right there electrically. There's 2 wires on the outside of this tape, one for the body and one for that pin, that electrode in the middle. And when that circuit is complete, this instrument will make a nice beeping noise for you. That's it. Really simple device. Kind of hard to believe, but this piece of equipment right here cost about $600. So I guess you get what you pay for, right? So if we wanted to figure out the water table elevation, then part 1, the first step, would be determining what's called the depth to water, the DTW. So how deep is it from the top of the well, or what we call the top of the casing. Casing is the plastic pipe around the well, to the water table. So I'll just lower this down until I hear a beep. I need to turn the sensitivity up. Keep going. Oh, there it is. And so what we do is we lower this down until it just begins to beep, and then we pull it out till it just stops beeping. We do that back and forth until we figure out the exact moment, the exact length that we have to lower this thing down to get it to beep, and that's called our depth to water. So I'm going to pull this out a little bit, and I'm going to find just where it starts, and I'm going to pull it out just a smidge, and there we go. This would be our depth to water for our first well, which is PZ1. So PZ1, take out my Write in the Rain notebook. PZ1 has a depth to water of, it's like 5.95 feet. So I'll write this down and I'm good to go. So here's our water level indicator right here. You can see basically a tape measure, bunch of numbers on it. Red numbers are feet, black numbers are tenths of feet. The little dots that we have in between the tenths of feet are hundredths of feet. The shorter bars, those would be 1/2 of a tenth of a foot, or 5/100ths of a foot, or 0.05 feet. So you can see, I've dropped this thing down the well. Not sure how far you're going to be able to watch it. Sometimes if the sun's right, you can actually see the groundwater, but can't today. We're in the shade. And I'm right at the level where that starts to make a beep. So I can show you. Just drop this down just a little bit. There we go, beeps. Pull it out a little bit, it stops. So you can see just how precise this is. And I'm right there, not quite at 6 feet. There's 5.9 feet, and I'm right at this bar where the top of the plastic is. Sometimes you can pinch it and pull it out, and that says 5.9, and that little bar right there is 5. So 5.9 feet for PZ1. Okay, so we have the depth to water for this particular well right here, PZ1, but depth to water doesn't necessarily give water table elevation. What I really need to know is I need to know the elevation of this top of the well. So if I have the top of casing elevation, then I could subtract my depth to water and bring me down into the ground where the water table is actually located. If I have that information, then I can calculate the groundwater elevation at this point.
You may find yourself living in a shotgun shack, and you may find yourself in another part of the world, and you may find yourself behind the wheel of a large automobile, and you may find yourself in a beautiful house with a beautiful wife, and you may ask yourself, well, how did I get here? Letting the days go by, let the water hold me down. Letting the days go by, water flowing underground into the blue again. After the money's gone, once in a lifetime, water flowing underground. And you may ask yourself, how do I work this? And you may ask yourself, where is that large automobile? And you may tell yourself, this is not my beautiful house. And you may tell yourself, this is not my beautiful wife. Letting the days go by, let the water hold me down. Letting the days go by, water flowing underground into the blue again. After the money's gone, once in a lifetime, water flowing underground. Same as it ever was. 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 Water dissolving and water removing. There is water at the bottom of the ocean. Under the water, carry the water. Remove the water at the bottom of the ocean. Water dissolving and water.
So here's my final data set. Everything looks good. And you'll have these to work with. Note, we got a dry well at MW1, and the very last one, PZ14, was dry as well.